Hello everyone, this is Dr. Indradeep Kumar, Assistant Professor, IARE, Hyderabad. So in this video, we will see the problem solving on Euler's and Rankine crippling load. So here, we will see how to find the Euler crippling load and Rankine crippling load. Okay. So let's see. The question is, find the Euler's crippling load for a hollow cylinder. So that topic is numerical on crippling load by Euler's formula. So first we are seeing for Euler and then we will see for the crippling one. So find the Euler's crippling load for a hollow cylinder steel column of 38 mm external diameter. So just see, given is what? Again same, when you are solving the numerical, just write the given data whatever is given. So external diameter, let's capital D as external diameter. Okay, or just simply you can write, so just see here. So external diameter is 38 mm and 2.5 mm thick. So after subtracting this, we will get the internal diameter. Take the length of the column is 2.3 mm. So length of the column is 2.3 mm and hinged at both ends. Take E equals to 205 megapascal. Also determine the crippling load by Rankine formula. So here in this both is required using constant as 335 megapascal and that alpha value is required for crippling load, that is 1 by 7500. So now just see given. External diameter 38. So internal diameter will be what? This is 38. Okay. So 38 minus 2 into 2.5 because both side 2.5 diameter will be there. Like suppose this finger is there or this one. So this is 2.5. This is 2.5. So this will be what? Total we have to 2 into 2.5 we have to reduce. So that total becomes 33 mm. Thickness is given as 2.5. Length is given as 2.3 mm. Now E is given as 205 gigapascal. After converting into Newton per mm square, it's 205 or 205 into 10 to the power 3 Newton per mm square. Sigma C is given as 335 megapascal. That is 335 into 335 Newton per mm square. And alpha is given as 1 by 7500. Now, so whatever is required, just find according to the formula. So just see, first we are finding area. So area is what? Pi by 4 into capital D square means external diameter square minus internal diameter square. So after solving this, what you will get? 278.8 mm square. So now we have area. Now find moment of inertia. So what is moment of inertia for hollow cylinder? That is pi by 64 capital D power 4 minus small d power 4. So I is pi by 64 38 power 4 minus 33 power 4. So after that you will get, after solving this one, 44,140 mm4. Okay, so this will be the value of I. Now finding radius of gyration, that is k square. So k square equals to I by A. So what we have, that k square 44,140 divided by area we found 278.8. Right. So after simplifying this, after solving that, you will get the value of k square as 12.6 mm. Okay. Now whatever the given data is there, and from that data what we can find, that we found. Now just use the formula. Okay, so now formula is YSC. For crippling load this k square is required, that for Rankine, so that's why we found. So first Euler's one. So Euler's load is given by what? PCR equals to pi square EI by L square. So pi square E is given as how much? 205 into 10 to the power 3 into I we found 44,140 divided by L is given 2.3, so 2.3 square. So after simplifying this, what you will get? PCR as 1.6 into 10 to the power 10 Newton. Okay, so this is the Euler's load, that P crippling load from the Euler's formula. Now what we have to find? By the Rankine's formula. So Rankine's formula is here what? PR equals to sigma C into A divided by 1 plus sigma C by pi square E into L by K whole square. And this just we found that this is the A, that alpha value, or you can see just here this is the alpha. Right. So now what we have, let's see. So after putting the value sigma C here, sigma C was how much? 335 into A, area was 278.8. Okay. This divided by 1 plus alpha is 1 by 7500 into, now L by K, L is given that as 2.3 divided by K square, we got 12.6. That's why we just here L square by K square. So simply you can write this L square by 12.6. Okay, L square by K square. So now, so after solving this, what you will get, that is here, just here. Just instead of writing this, just I wrote here in the same line. So just here 335 into 278. This whole divided, right, by this whole thing. So 1 plus alpha is here 1 by 7500. Okay, plus 2 by 2.3 by 12.6 square. Okay, so now from here, so after simplifying, what you will get? P Rankine as 76312.6 means 76,312.6 Newton. Okay, so from this, that P Rankine we found. Okay, so let's see once again quickly. In the question, it's given what? External diameter as 38 mm. Internal diameter as 2.5 mm thick is there. Means from the all the side it will be 2.5 mm thick. So when we will find, or just see here like this one, this is given, or here thickness is given. So it will be all the side, right? So this is given as 2.5, and this total from here to here is given as 38. So this side 2.5, this side also will be 2.5. So after subtracting what? 38 minus 2.5 minus 2.5. So that is 33. Okay. Length is given 2.3 mm. E is given. Okay. Then we have to find what? Rankine's, that crippling load, and Euler's crippling load. The alpha value is given and sigma C value is given. So these are the given data. Okay. So now with this data we have to what? We have to just put into the formula. Right, so first formula, whatever the things are required. So first we will find that one. So with the given data, we can find A. So formula for A is pi by 4, capital D square means external diameter square minus internal diameter square gives how much? 278.8 mm square. Now that moment of inertia, or here you can write that moment of inertia. Okay, so moment of inertia is what? For a hollow cylinder, it's a pi by 64, external diameter power 4 minus internal diameter power 4. So pi by 64, external diameter 38, so 38 power 4 minus 33 power 4. That gives how much? 44,140 mm power 4. Now, next, that is required what? Radius of gyration, GY. Okay, so for that formula is simply, because we know that I equals to A K square, right? So from here K square will be equals to what? I by A. Already we have A, we found I. So simply just put, so I is how much? 44,140 is 44,140 divided by A is 278.8. So this is K square. So after simplifying, you will get here that is, sorry, this is the K value. So K is 12.6, not K square. K is 12.6. So from here you got K. Now just apply the formula. Okay. So now formula is what? PC equals to that PCR crippling load. That CR stands for crippling. So PCR equals to pi square EI by L square. PCR equals to pi square into the E is 205 10 to the power 3. I is this one. This divided by, okay, 2.3 square. So PCR is 1.6 into 10 to the power 10 Newton. Now by Rankine's formula. So Rankine's formula is what? Sigma C by 1 plus sigma C by pi square E. This is only the alpha by LK square. So simply we can write sigma C equals to 1 plus alpha into L by K whole square. So now everything we know. Let's put the value. So after putting the value, what you will get? 335 into 278, this value, whole divided by 1 plus alpha is 1 by 7500, L is 2.3, K is 12.6, that whole square. So this is whole square, this is not 2. Okay. Okay, so after solving this, you will get PR equals to 76,312, that is 76,312.6 Newton. So just see the difference. PCR is how much we are getting. Okay. 1.6 into 10 to the power this one, and here we are getting this one. So Q, that Euler load is too much high compared to this one. Okay, now the second question. a steel rod 5 mm long and 40 mm diameter is used as a column, right? So suppose this is in a starting, that is just a column with one end fixed and the other free. Determine the crippling load by Euler's formula. Take E equals to 2 into 10 to the power 5 Pascal. So now what is given? Length, that is steel 5 mm long. Length is given and diameter, so 5 meter, and here 40 mm is there. That 40 mm diameter. So either just convert this into meter or this convert into mm. Right. So now load should act here, but condition is one end fixed. So this end is fixed and this side it will be there. So now this will shift here by small that amount A. Already we derived this for this also. Right. So see, length of the steel rod 5 meter. Okay. Diameter of the steel rod is 40 mm. Condition given, that is what? One end fixed and other free. What we have to find, that is crippling load. And E is given as 200 gigapascal. That is only T into 10 to the power 10. Now calculation. So again what we will do? First we require to find I. So I will be equals to what? Because this is solid, this is not hollow. So in this time I will be equals to, that moment of inertia will be equals to pi d4 by 64. Now put the value of this one. So pi into d4. So 40 power 4 by 64. So now just see, in mm only we are calculating. So 125,663.706 1 mm power 4. This value we got. So now moment of inertia in terms of mm only we got. Okay. Now calculation of crippling load. So just same formula, pi square EI by 4L square, because this is one in free and the other is fixed. So for that, P is pi square. So P CR is pi square EI by 4L square. 4L square. Now put the value. Pi square is simply pi square. E is given 2 into 10 to the power 5. Okay. And I just now what we got? Let's see here. This one 12566.3 mm power 4, or simply after converting into meter, this you can write here. Let's see, 0.126 and 0.125 into 10 to the power 6 whole divided by what? 4, and L square. L is how much? 5 meters. So that becomes 5,000. So 5,000 square. Okay. So after simplifying, okay, what you will get here? Just pi square EI by LE square. So after okay, so here this one is there. So just after solve, you will get the Euler's crippling load. Now, and the Euler's buckling load, that is PE, is pi square EI by LE square. So pi square E, actually this is for different one. This is not for that one. Okay. So this is, I think it's just for second question. So just this, remove this one. Okay. So now let's see once again question number 2. So what we have to find, determine the crippling load by Euler's formula. So what is given? Length is given 5 meter, diameter is given, and of solid is given, diameter used. It's not hollow. Okay, with one end fixed and the other free. So this is the end condition, and E given. So now again just given data. Okay, and after that what is required? I, because the formula is pi square EI upon 4L square for one end fixed and other free. So in this case I is required because E given. Pi square is constant, L is given. So only the thing is we have to find I. How we will find I? For the diameter is given. So I is equals to pi by 64 d power 4. So after finding this one, means here change all the length into mm. This we are using in mm only. So the total length, this also will be equals to 5,000 mm. Okay. So after finding this, we got 125,663.706 10 to the power 6. So just take this side. So we can write 0.125 into 125,663, okay, into 0.7061, this into 10 to the power 6. So instead of writing these many, because as we will move away from the decimal, that becomes smaller. So simply just we can take that as 0.125 into 10 to the power 6. Okay, mm power 4. So this is the value of I. Now just put, okay, in the formula what? P equals to pi square EI by 4 square. So pi square into 2 into 10 to the power 5 into 0.125 into 10 to the power 6 divided by 4 into 5000 square. Either you can just simplify this one, or you can simply put into the calculator directly, you will get the answer. So that will be there. Okay, so this is not the part of this question. So just remove this one. Okay, so now clear how to find the crippling load by Euler's formula and by Rankine's formula. Just you have to remember the condition. That's why just see in the previous form what we used. See the difference here. In this case we used pi square EI by L square. But now in this case we used pi square EI by 4 L square. That is the difference only based on the condition. What condition is there? So in this case, this case one end is fixed and the other end is free. That's why, and in that case LE is equals to 2L. And what is the formula? P pi square EI by LE square. So LE is here 2L. So that's why it becomes pi square EI by 4L square. So that formula. So you have to see which condition is given. It's not like that simply. The condition is given means definitely some meaning of that condition will be there. And according to that only the equivalent length will be there. So that equivalent length, according to that only you have to take. Don't confuse with the equivalent length and use the same formula. Based on the condition, what like both end is fixed, both end is pin or hinged, one end is fixed, one end is free, or both end fixed. So whatever the condition is there, in that condition, each condition have the different equivalent length. That equivalent length you have to remember, and then according to that the substitute. The remaining formula will be same, only the equivalent formula will be different with the condition of how that is there. That one end fixed. So here one end is fixed. Okay. So here either you can refer this. Actually, this also is in directly PDF. If you will search this one, directly you will get this question. Or another, the second question is from what? Question of numerical problem on column and strut civil engineering by Naga 3 in 2016. She prepared this question bank type. So you can refer also for this question. Okay. So if you have any doubt, you can just comment on the video or just contact me regarding your doubts and clarify your doubts. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.